If you've ever wanted to have a clear understanding of SQLite in Flutter, which we refer to as SQLite, then this series is for you. Hey friends, welcome back to the studio. In this tutorial, we'll explore how to use SQLite database into our Flutter applications. The timestamps to the different lessons of the tutorial will be listed in the description because I value your time. So let's get to it. I'm also thrilled to share that I've kicked off a newsletter. If you're up for a dose of exciting updates and interesting tidbits from yours truly, check out the link in the description. We'll have a look at what SQLite is, the benefits and the drawbacks of SQLite, why we should use SQLite, when to use it and when not to use it. We'll also set up SQLite in our Flutter application, define a schema, define a contract class, design a simple custom SQL helper that will help us in creating implementations that interact with our SQLite, that is reading, writing, updating and deleting. We'll also have a look at batch processing support and look at the difference with transaction processing, and we'll also have a look at database migration and testing, and lastly we'll have a look at best practices and tips. So what is SQLite? SQLite is a lightweight relational database engine that operates as a standalone single file database embedded into an application. It is used to manage structured data in applications. That means data is organized in tables where each table consists of rows and columns. Android stores the SQLite database in your app's private folder. On Android, it's typically data, the root will be databases, and on iOS, it's a documents directory. Your data is secure because by default, this area is not accessible to other apps or the user. So what are the benefits of SQLite? SQLite's serverless single file structure enables straightforward integration into mobile apps without the need for a separate server, making it ideal for projects where simplicity is key. The database's single file nature enhances portability, allowing easy distribution across platforms, while its low resource usage ensures efficient performance, especially on devices with limited resources. And lastly, SQLite provides transactional support, ensuring data integrity, not as good as other complex or advanced local data storage solutions, but it does have that small aspect of it and provides benefits to offer different options to be able to store and perform transaction processing. Some of the drawbacks of SQLite are SQLite may face performance issues with concurrent read and write operation as it locks the entire database during a write transaction. Also, SQLite may face challenges in handling large datasets or applications with high transaction rates. In this case, you'll need to use a more advanced data storage solution. Also, SQLite lacks advanced access control features compared to, of course, some server-based databases. And lastly, SQLite is a serverless database, which means it lacks server-side processing capabilities like synchronization and all. While this simplifies deployment, it might be a drawback for applications requiring complex server-side procedures or where centralized data processing is essential. So why would you use SQLite? SQLite serverless architecture and single file database design make it incredibly easy to integrate into mobile apps without the need of any complex setup or administration. We'll get to see that. And also the single file nature of SQLite databases enhance portability, making it convenient for developers to distribute the applications along with the database file. Also, SQLite is designed to be lightweight and has minimal resource requirements. SQLite adheres to ACID properties. ACID means atomicity, consistency, isolation, and durability, and provides reliable transactional support, but only for small data sets. For complex one, we have more advanced data storage solutions for that. Since SQLite operates a serverless database, it eliminates the need for a separate database server. This simplifies the concept of deployment and maintaining the database. Also, it has a large and active community of developers, and we have seen certain data storage solutions that have been designed on top of SQLite. Then we also have for rapid prototyping and development cycles, SQLite is very good because it offers a quick and straightforward solution if you want to create a very quick prototype for testing or for testing an idea or presenting an MVP, for example. So when will you use SQLite? SQLite provides a reliable and efficient way to store structured data locally. So you can create tables to represent entities in your app. You can also use SQLite to to enable your app to function even when there's no internet connection. So it provides that offline functionality. It also supports SQL queries, making it suitable for complex data retrievals and manipulation. We'll get to see that. And lastly, SQLite supports relational databases, allowing you to define and manage relationships between tables. So we wouldn't use SQLite in certain situations. It may not be ideal for when you're handling massive data sets or complex data processing tasks, as I mentioned. And also, SQLite is a local embedded database. While there are ways to share SQLite database across platforms, it might not be the best choice for scenarios requiring centralized data storage or cross-platform collaboration, which it's a drawback in a number of local data storage solutions, right? Those mainly that do not have the concept of data synchronization. So now let's proceed to set up our SQLite in our Flutter app application. Let's create a new Flutter application by running the command flutter create a shopping app. We'll create a simple shopping app that allows the user to create a shopping lists, and in each shopping list they are able to create items for those specific shopping lists. So for example, you might have a shopping list that revolves around home, call it home list, and then inside the home list you'll have items that are home stuff. Okay, so click enter on that, and then you'll find that we'll have our Flutter application created, the same type of folder structure. And then now the next thing we need to install is the most important dependency, which is SQLite. So just say flutter pub add SQLite. It's the SQLite plugin for Flutter. Okay, so click enter on that, and we'll get to have it installed version 2.3.2. Great. So now that we have that, we'll proceed to our main.dart. We'll just close the terminal. And the first thing we're going to do is talk about the schema. So let's do that first. So a schema is a declaration of how the database is organized. So we have a simple schema for our shopping list app over here. So our shopping list will have two fields, an ID and a title, and then we'll have a table for shopping item which will hold an ID, the ID of the list that this shopping item belongs to, a title for the item, quantity in terms of number, unit in terms of type, that means either it's 5 bottles, 10 pieces, and then price will have the amount, and then done is to show whether we have selected or bought our item or not. So it will be a Boolean type. Great. Now that we have that, let's head over back to our application and do the first thing, which is define a contract class. So I'll just create a new folder here, call it utils, and then I'll head over and create a new file called contract.dat. So what a contract class is simply, it's just a class that consists of constants that define the names for the tables and the columns that we're going to design for our schema. So it allows you to use the same constants across all the other classes in the same package. So you don't have to manage strings within the app. You just have one place where you have defined your tables, the name of your tables and your classes, your name of your tables and your columns, and all you have to do is now just call the variables, and in case you need to change anything, you just come and change it in the contract class. Good. So let's define our contract class. We'll give it the name shopping contract, and then let's define a private constructor for it. And now let's proceed and to define our constants. So first thing, we'll have the database name. So our database name, we'll call it shopping.db, and then we'll have the version. Let's give it the version of 1. Then now let's define our first table. Shopping list is equals to shopping list. Then we'll have the columns. So our first column will be list column ID. We just give it the name ID. Then we'll have title. Then we'll have shopping item table, shopping item, and give it the name shopping item. So the fields or the columns for this specific table we'll start by the ID, then we'll have the list ID, then we'll have the title, we'll have the quantity, we'll have the unit, we'll have the price, and we'll have done. So there is our contract class. Now let's proceed to create a custom SQL helper. So we'll just create a helper class that will manage all our database creation and methods, and allow us to create and maintain the database and tables in one specific class. So this is where we'll interact with the SQLite. So I'll just create a simple file called SQL helper. And this is where most of the magic will happen before we design the interface. So the first thing we'll do, we'll create two models, one model that represents the shopping list and another model that represents the shopping item. Okay, so let's define the first model and name it shopping list. And then some of the variables that will hold that will represent this specific model will be the ID. Then we'll have this title. Great. And then next thing we're going to do, just define the constructor and say required this.id, required this.title. There we have it. And then the last thing we're going to do, we want to be able to convert it to a map. So we're going to create a simple function for that. We'll call it toMap, and it will return a type of map, string object. So inside here, we'll define a variable called map. We're expecting to return this type of map, and then we'll just call shopping, our shopping contract, and proceed to call the title of this list column title, and define it with a title. Let me show you. So what we're doing is we're designing a map based on whatever we receive. So we're going to be picking the name of the column for this specific table, which is title, and assign it the title. Okay, so let me see if there's something wrong with this code. Okay, we are just using the wrong, there, supposed to look something like that. So we're just designing a map. So the key will be the name of the column for title, and then we give it the value that will be passed in this when designing this model. Okay, then the next thing we'll do is we'll say if id is not equal to null, we'll proceed to add another value in the map. Call the name of the shopping contract list column ID. This is the name that represents the column ID for the shopping list table, and then assign it the ID. Then all we have to do here is return the map. You'll get to see how we'll need this. So now let's design again the shopping item model. So I'll just proceed to define a class here and name it shopping item model, and we'll have the same thing. So some of the fields that we'll have, the properties will be an ID, we'll have the list ID, we'll have a string, we'll have quantity, we'll proceed to have a string unit, we'll have price, then we'll have done of type bool. So let's design our constructor. Shopping item model required this dot id, required this dot list id, required this dot title, required this dot quantity, required this dot unit, required this dot price, required this dot done. There we have it. And then we'll also design the function. It's similar to this one. I'll just pick it and add it here, but now we'll call the respective values. So we'll have item, column ID, column list ID, and pass in the list ID. We'll have shopping contract dot item title, and return the title. Just add a comma here. Next will be shopping contract item column quantity and pass in the quantity. Shopping contract item unit, yes, and then we pass in the unit. Shopping contract item price, pass in the price, and lastly we'll have shopping item column done, and we'll pass that. Great. So if the ID is not equal to null, that's when we'll proceed to call the item column ID, and we're done. So we have our two models ready. Now let's work on the SQL helper. These are just models that I inserted in the SQL helper file. Now let's create our SQL helper that will hold all the operations revolving around SQLite. I'll give it the name shopping provider, or better yet, helper. Okay, let's start by creating a database. So I'll just import SQLite package, import package SQLite. There we have it. And then we'll proceed back to our class and declare a simple variable of type database. Name it DB. Wait, so now the first function that we'll have will be to open the database. So we'll just define a function called open. So one of the arguments that we'll have will be a string that will hold the path. So that's what we'll require when calling this function. So let's start by, I'll set this to future, define a sync, and inside here we'll proceed to define or to initialize the database. So we'll say db is equals to await open database, and then we'll give it the path, but we're also going to add a few more things. For example, version. I mentioned we're going to talk about data migration somewhere, so we'll get to see why it's important to set the version. So we'll get the version from our shopping contract database version. Great. And then we're going to have on create, and on create now we're going to have our next function. That's the one that we're going to plug inside here. So let's create it first. And before we create it, because we're going to deal with a certain concept called transaction processing, let me mention what it is first. So a transaction is a sequence of actions performed on a database, and it must either succeed, the whole of it as a whole, or fail completely without leaving the system in an inconsistent state. So when we're performing a transaction, or in this case we're going to perform transaction processing, we're going to state all our actions, which mainly are creating our two tables, creating the shopping list table and also creating our shopping item. So that's the transaction that will require two operations involved. So it will either succeed, that means both tables will be created, or fail completely, that means it won't change the consistency of the database. So let's create that function so I get to show you now that I have mentioned about transaction processing. And if you want to learn more about transaction processing, I do have a simple article that I had written on Medium, and I just give a few details of what transaction processing is, the concept of asset properties, process of transaction, and you can also head over there and follow so that you get to see other more articles that I write on Medium. Okay, now back to our application. So I'll have a simple function called onCreate. And this is the one that I'm going to copy over here. And then let's proceed to define it. So it won't have any return type, so it will be of type void. And some of the things we will need to be able to create our table or our database will be the database instance or the variable db, and then we also need the version. Then I'm going to set this to async. Now for transaction processing, this is how it works. We'll call the database and then we'll call the method transaction. Okay, and then we go inside here is where we're going to define our operations that will be in this transaction. Okay, so our first transaction is we want to create a table called shopping list. So we'll just proceed to say await, and then we use this specific variable that we have has been passed inside here, txn dot, and then we call the method execute. And then now we add our SQL query. That means it will be an actual string. For example, create table this. So let's write it down. So I'll just add quotes. So I'll add everything between here. So what will be our SQL query? It will be create table, and then we proceed to call the name by just using the $, and head over to our shopping contract dot table shopping list, and then we'll proceed to finish our query by calling the specific columns that we're going to have in our table. So the first one will be shopping contract list column, and we're going to define it as an integer, and it will be the primary key, and we'll allow it to be auto incremented, so we don't want to set the ID manually here. Then the next thing we'll have is we'll have a title, so list column title, and what we'll set here is it will be of type text and not null. So that's our first SQL query that will create for us the table shopping list. That looks neater. Okay, now the next thing we're going to have is another one. So after this we'll have await. So within the same transaction we want to execute another operation, and now this one will be for creating the shopping item table. So we'll have create table. I will say that creating the SQL, the string itself, this is one of the, I feel like one of the drawbacks compared to like more advanced local database or data storage solutions like ESA database, Hive, because now those guys, they do use ORM, so you don't need to create a whole string, because if I do make a mistake here, it won't create. If I end up adding the wrong a column in the wrong place and all that, it will fail. But let's proceed. I just wanted to mention that out. So we'll pick the table name, shopping contract dot table shopping item, and then we'll proceed to create our fields. So our first field will be column ID, which will proceed to be an integer, primary key, auto increment. So if I end up misspelling auto increment, the execution won't occur, it will fail. So those are the drawbacks of like SQLite, but these amazing data storage solutions have come up that are running on top of SQLite are awesome, and they use the concept of ORM, so you don't need to do this. You just call the methods that are already executing, creating these SQL queries for you. Next thing we'll have is shopping contract column list ID, and this one will be an integer. Next we'll have shopping contract item column title, and it will have text and not null. Then we'll have shopping contract dot item quantity, and we'll have it in type double, and we'll just set a default for it and make sure that it's not null. Then we'll have another one, shopping contract dot item column unit, and this will be of type text, and then we can set the default to kgs, not null. Then next we'll have shopping contract, then we'll have price, be of type double, default we'll set it to 0.0 and set it to not null. And lastly we'll have contract done, and this will be of type integer. Booleans are saved as integers, either 1 or 0 in the database, so you don't save true or false in a relational database, that is. Okay, now we're done with that. So our onCreate is complete, and we have injected it at this point. So at the moment we call this function open from our SQL helper, it's going to create our two tables using the transaction processing. It's going to be in form of it will be a transaction that will be executed to create for us the two operations. Instead of having individual executions, you can use transaction. Okay, now the next function, let's proceed to the next. Let me just format this so it's readable. Yeah, I think that's okay, right? Great. Okay, then let's work on the next function. So in the next one, we're going to do a lot of writing, reading, the CRUD operations: create, read, write, and create, read, update, and delete. So let's start by creating a simple function that says insert shopping list. And then let's give it a type of future. Let's think. So we're going to call the database. So we already have it inside the class db.insert, and we need to specify our model is called shopping list model, so we'll pass it here. And then we're going to call our table contract dot table shopping list, and then we'll proceed to add a value that will be of type shopping list model. So we'll just proceed to call shopping list, and then we're going to convert it to a map. We're converting our object to a map. Okay, so what is returned here is an ID. So you want to come here and say shopping list.id, because it has an ID, an attribute, a property, or a field called ID. We want to initialize it to whatever will be returned here. That's what you've done. And then yeah, it's complete. Then we'll get to proceed to create the next one, which will be get shopping list, which is reading get shopping list. So if we want to get a shopping list, we need an identifier. First, before that, let me just define what we need returned, which is shopping list model. And I'll just add this, and then what we want to use as a to help us get this shopping list is the ID. So I'll just do a simple try and catch. So we'll call our database db.query. We'll call the query method and define the table that we want to query, which is table shopping list. And then we proceed to define our columns. So what we need is the ID and the title returned. Great. Let me just close this. And then after this, we're going to have a where condition. So we say where, then we specify our value. What do we want to check? Which field do we want to check exactly? So we want to check the field shopping contract dot list column ID. That's what we want to check. And then you add this. So what will happen is, I forgot to enter the semicolon. When we add now our arguments, the where arguments, which ours is specifically ID, it's going to proceed to replace our question mark with this specific ID that we pass. Okay, and then the last thing we're going to do, let me add, we're not yet done. So now that we have that, whatever will be returned will be a list. So if it's int of type, if it's returning a list of shopping lists that has this type ID, it's going to either return one shopping list or more depending on the database, but ideally ID is unique, so it should return just one, but it will return it in type list. So we need to get whatever is being returned, so we'll assign this to a list, a variable of type list map. So we'll just assign it like that. And then the next thing we're going to do is do a return. So after this part, we'll just say if the maps, whatever we have, or instead of saying maps, let's just say shopping lists. This will make sense. If shopping lists dot is not empty, then we can proceed to return our results. So we'll just say shopping model, list model. We need to convert now whatever we are getting. So we created two map function or a method that will convert for us from object to map, but now we didn't create another method that's called from map that will convert our values from map to the object itself, the shopping list model. So let's add that. I missed that. So all we have to do is say shopping list model dot from map, and then we're going to pass in the type of map that you want to convert. And inside here, all we have to do is call the property and then pick from the map shopping contract dot list column ID as int. We missed this, so let's do also title. So it will be map shopping contract dot list column title as string. So there we have our values. Is equals. I don't know why I keep confusing. Okay, so now this will allow us to convert a map into a specific shopping list object or model. So let's do the same for the shopping item model. So I'll just come here and define all of them. So we'll have item, then we'll have ID, and this will be item column ID. Then we'll have title, which will be item column title. Next thing will be list ID. List ID as int. Next, quantity. As double. Unit. As string. Price. As double. And lastly, done. There we have it. Now let's work on, why do we have an error here? Let's just finish this. So now we can proceed to call from map, and then we just pass our map dot first shopping list, because remember each ID is unique, so we're not expecting multiple shopping lists with the same ID. As I mentioned, even if it returns only one, it will return in type of list. So all we're doing is just picking the first value, or like index 0 if it was, that's another way of saying it. So now that we have our try, we have added this. Let's now work on our catch. I need to check why we have an error on this. There we have it. Okay, it was my mistake. So now let's handle catch, and we can use the database exception class to do this. and we'll just call catch, return null, so we set this as nullable. There is our next function, which gets a shopping list. Now let's proceed to the next one, which will be getting shopping lists, all of them. So we'll just say get shopping lists. We'll do a future that will be a type, a list of type shopping list model. We'll set it sync because we'll have an await operation, which is the same one. We're calling the database, calling the query method, and then now we specify our table, which is shopping contract dot table shopping list. But then there's a list that's being returned here, so let's initialize it to a variable and just say shopping lists. And then next thing is now to loop through so that you can convert these objects into shopping list model type, into an object. So it's from map to object. Okay, so I'll do this quite fast. So I'll have a simple variable call of type shopping list model, and I'll just call it lists is equals to this, and then I'll just say if shopping lists is not empty, we now proceed to do a for loop for map shopping list in shopping lists. So I'll just say lists dot add. We'll pick our model, shopping list model, and call our method from map and passing the shopping list. And then once you're done with that, we'll return our lists. So let me see what's wrong with this. Oh, there we have it. Okay, so we're done with get shopping list. Next will be delete shopping list, or let's do an update first. Update shopping list. So it returns an int, and whatever we need to pass here is the object itself that we want to update. So it will be list model shopping list, and then we just do call our function await, call our database, and then we'll call the method update, and then specify our table shopping contract dot table shopping list, and then specify our values. So for our values, all we have to do is pick our shopping list and then say to map, because SQLite does not understand the specific the customized objects that we have created, so we have to convert them to a map. So that's what we're doing. And then another thing we need to specify is where, and then we'll just call our ID column shopping contract dot list column ID is equals to question mark, And then now we add our argument, which is being represented by the question mark, which will be shopping list, the ID dot ID. Great. And then whatever will be returned will be of type int, and that's what we're going to return here. Now let's work on delete. So for our delete shopping list, we'll need to specify which the ID of what we're using as an identifier to delete. And then we'll just set this to async because we're interacting with a database. So we'll just say await db dot, we call the method delete, and we need to specify the table contract dot table shopping list, and then we specify the where. Let me just close this, and then I'll just create a variable because an int will be returned, the deleted ID. So after this, what we're going to proceed to add is the where. So we're just going to say call our field, which is shopping contract dot list column ID is equals to question mark, and then I specify the arguments, which will be our ID. Great. So then we're going to return our ID. Great. And then now, because because items are inside our shopping list, when we delete our shopping list, we'll need to delete also the items in that shopping list. So we'll get to add that logic here in the shopping list. Let's first finish. I think we're even done because we've done the CRUD operations. We have read, we have created, we have updated, we have deleted. So next thing is inserting, working on the shopping item. And to make work easier, I'll just proceed to copy whatever I have here, which is for insert shopping list. So we'll come back to adding this. I'll just have insert item. And what I'll pass here is the item. Just name it item. So we're just making some changes. This will be table shopping item. And then we'll just say shopping item dot to map. So we're done with that. We can return this shopping item model. So we'll just return once it's inserted. The next thing will be get shopping item. So we already have a get shopping list here. So I'll just proceed to copy this and set it here, then make the changes from item, and then we'll have shopping item. Our table will be table shopping item, and we're going to be now setting the column. So we need item column ID. We also need item column title. Next thing we need is item column quantity. Next thing we need is unit. Next thing we need is price. Next thing we need is done. There we have it. And then now we come here and specify shopping contract item column ID is equals to the specific ID that has been passed in this when calling this specific function. Yes, and then let me just change this so that it's not confusing. So I'll just say shopping items, and then we'll just call our respective model and then specify shopping items, and we are done. Great, now let's get shopping items. So just proceed to pick this and then just specify our model, which is item. Define our function as items, and then let me change the variable name here, and then call the correct table, and then specify the correct model that we're using, and then I just call the correct variable shopping list, shopping items, and then I'll just say shopping item, and then specify the correct model from map, then I just say shopping item. Done. So let me see, get shopping items. So in this case, so get shopping items, but now here's the thing, we're going to get the shopping items, but what we need is per shopping list, the items in a specific list, right? So we'll need to pass an argument here. We'll need the list ID so that we know how to search it. So we'll just come and say, so we have our shopping items here, but we need to do a where clause. Okay, let's just do that where clause. So we'll just say where. We can even specify our columns first, which are here. Let me just pick this as is to make work easier. So we have our column, and then we just come in, instead of item column ID, we'll say item column list ID, and then what we'll pass here is a list ID. So it will return for us all the shopping items revolving in a specific list ID, and I think that's what we actually need, and not the other way, not getting all the list items. Okay, so we have that, and I think this one is good to go. Next thing is delete shopping item. Let's delete shopping item. I think we have it somewhere here, and this is where we'll come and update that part as well. So I'll just say delete shopping item. So let's specify our table shopping item, where item column ID is equals to whichever ID has been passed here. So it's simple as that, and then we'll just we don't need to return anything, just do a return like this. That's fine. Now let's go back to our delete shopping list and now complete whatever I was talking about here. So what I was saying is that as much as we're deleting the list, we need to delete the items in that specific list. So we'll just say await db dot delete, and then we specify the table for shopping item, where let's call the field shopping contract dot item column list ID, close that. So our where clause will be the ID that's in, oops. So what we have said is that delete in table, the shopping item table, where the item column list ID is equals to this list ID, the ID of this specific list that we're deleting. So it will delete all the items within this list. So as much as we're deleting the list itself, we're deleting all the items in that specific list. Okay, great. Now let's do the last one, which is update shopping item. So we'll have just changing the model, changing the text, and then we just do a return update and we specify the table shopping item, and then we'll just call the shopping item dot map, and then we'll just specify the item column ID and pass in the shopping item dot ID, and we are done. So we have performed the main CRUD operations on the two specific models. Let's add what else can we add? One more thing we can do is I want to talk about batch processing. So there's usually a conflict between what batch processing is and transaction processing. We've been able to see how we can perform transaction processing in SQLite, but when dealing with sometimes you may need to perform multiple database operations, but in terms of batch. So it allows you to group these operations into like a single transaction, but there's a small difference between batch processing and transaction processing. So batch processing, it just executes on its own, just creating as it goes. It does not have a specific conditioning. You see, for transaction processing, either all the operations have occur successfully, okay, and then the database is updated and stays consistent, or it fails altogether. Either it succeeds, all the operations succeed as a whole. If one of them fails, the transaction will not be executed. But batch support, what happens is you're just creating a batch of maybe insert operations that will be executed in the process. Just it's, how do I explain it? It's similar to how check clearing works. You create a check, you need it to be cleared, but it won't be cleared at that point. It will be cleared over time because there are certain processes that need to be happening, but it will happen in the background. So we're going to show how batch processing works in SQLite. I'm just going to do this. We inserted a shopping list. We were able to create a function that inserts a shopping list. But I want to perform batch processing in that. I want at least 2 items to be added in the shopping list, just 2. So we'll have when a list is created, instead of it being empty, we just create 2 items inside each list, and then if the user wants to delete, it's fine. So that's just a way of showing you how batch processing works. So in case you have things that you really want to be created, or certain database operations that you want to be executed behind the scenes, you can use batch processing. But with transaction, you really need that update to be done. Like in our case, transaction processing, where we implemented it, we really need those tables to be created so that we can be able to do our CRUD operation. But for batch processing, like in this example, what I'll do is I just create a simple batch. A simple batch and call it batch, and then I'll just proceed to call my database and use the method batch. So I've just initialized a variable of type batch. Now I'll use it and use the insert method because I want to insert a few items specifically in the table shopping item. Sorry. And then I'm going to define a few values. So I'll just call my model shopping item model, and let's define our object. So we'll just remove the ID. We don't need the ID, to be auto incremented, and the list ID will be the shopping list dot ID, this one specifically. And then for the price, we can set it to 0. For the title, we can say vegetables, for example. For the quantity, we can just say 0. Unit, we can say kgs. Price, we can define as 0, and done, we can say false. So let me see. shopping item. I don't have to set this, the ID. I don't know why it needs me to set it. But after this, I'll just set it to map. Let's see why I need to insert the ID. I don't have to. So I think I set somewhere required, and that's a mistake I made. Also in the list, I don't require this. Neither do I require this. So there we have, our error is gone. So this is our first batch, our batch. This is the one batch. The batch will have the first insert operation, then we'll do another insert operation, so that when a list is created, there can be a batch processing occurring where it's creating for me 2 more items on the side. So I'll just copy this and just change the values. And say fruits, and then just leave the values as they are. So this is how you can perform batch processing in SQLite. Great. So the next thing we're going to do, I hope it has made some sense between the two. It's there's a thin line between differentiating between transaction processing and batch processing, but remember, transaction is has the ACID properties. Batch processing is just having a batch of operations that are executing behind the scenes, and that's why. So the key difference is timing and the nature of how the data is being processed. So the transaction processing has to be in real time. Like in our case, these tables have to be created now, and so that we can be able to proceed with other operations in it. But in batch processing, it can be a number of operations that are scheduled to occur in the background on their own. There's no specific time. And it involves, it's just a single process that's occurring behind the scenes. So for this one, we don't need an interaction within the app to be able to create these 2 inserts. All it does when we create this function of ours, it will create for us a list, but behind the scenes, it's performing a batch processing where it's creating 2 insert operations in our shopping item table. Okay, so now let's look at database migration, how that happens. So for data migration, we'll proceed to create 2 functions. So we'll have a first function that will upgrade our database. So we'll just call it on upgrade. So one of the requirements that we need is the database itself. We also need the old version and the new version. So in the process where you want to create an upgrade of the database, this is the function that you can use. In short, this is just a customized function that we've created, but now we need to proceed to the part where we open the database and call the attribute on upgrade. They do have that, and then you pass in your function. So what you're saying, at the point of on upgrade, it will be able to detect that the old version and the new version are not the same. There's a new version. In that, what I mean is, let's take a scenario where let me head over to my contract class. Let's take a scenario where we had published this app and it's accessible to users in database version 1. But then there's an upgrade or there's an alteration in in a specific table, and we want to update that. So the next push or the next version that we'll publish will be in version 2. Okay, so in case we set this to 2. Okay, so when we come here on the on upgrade, it will be able to have the old version and the new version. These are the 2 things that we'll need to check, and then we'll use the database for that. So for example, just giving a scenario, we may have a scenario where we want to alter a specific table. So we may say old version, and I can show you in this case. As you can see, there are 2 ints that are needed. So it's able to detect that the first int is an old version. Let me show you. So we have this function, it has the database and the int. This first int is the old version, the second int is the new version. So it will be able to detect this specific old version and the new version. So we'll head over here and say if the old version, which is the second argument, is equals to 1, that means we're trying to target the previous version that we had pushed take into consideration that we are currently in version 2, so we are trying to look to upgrade the users that still have the old version. If this is a case, we can do something like if old version is equals to 1, that means we're targeting the old. Let me just set this async. We can proceed to say await db.execute and add an SQL query here. An example of an SQL query will be alter table we may decide to change the table list and proceed to add a column. We may decide to add a new column like description. Let's say description text of type text, and then we close that. So any application that is already installed by users and the old version is 1, it will proceed to upgrade this. So at the point of creating the table, when the user decides to install this app and open the database, if the existing database is of old version, which is 1, it will proceed to update this database by altering it and adding a new column in the shopping list table that is called description. So that's how you perform upgrades in SQLite. Okay, so the next thing we'll do is, let me just comment this one fast. We'll have another function called, or better yet, let's just leave it as is. And then I'll have another function called on downgrade. It will also have the same features: database, db, arguments, old version, and the new version. Okay, so in this case, it's the same scenario over here, but now let me copy this. At the point of opening the database, we pass in a function in the on downgrade attribute. So we may add some logic inside here that requires us to downgrade. Maybe we want the new version, we want to remove a specific column, or we need to upgrade or concatenate a string in a specific column, the way the values will come in. This is where you get to do it. You're able to compare between the old version and the new version. You can downgrade it. Okay, so in this case, we're upgrading because we are changing something that is already in the new version into the old version. That's what upgrade is. But in downgrade, you may have something that is in the new version that you want to return it to the state of the old version. So that's why you add the logic here. Okay, so now let's look at finally designing the user interface and get to interact with all these functions that we have created so far. So we'll just close, we are done with the implementation side of things. Now back to our main.dart. So in our main.dart, we'll start by defining an instance of our SQL helper, which is, let me see, a shopping helper. So in our main.dart, just come here and define or declare an instance for it. I'll just import it. There we have it. And then before the run up, we want to be able to define and pass the path, because if in the SQL helper, one of the first things that we do before we open, for us to open the database, we need to pass in the path. So let's open it inside here before running the app. So I'll just use the widgets Flutter binding, ensure initialized, and then we just call our instance. And then we'll just define a path. Let me set this to async. We get this method from the SQLite package, and then now we just design the path. passing in the database path. So we are joining the database path together with the name of the database, and the name of our database, we set it as shopping.db. So this is what we are calling shopping contract.db name. We'll need this. Let me head over to my terminal. We need the path dependency. Okay, so back, let's just import it. There we have it. And then now we proceed to open our database, and we pass in our path. So there we have it. Next thing, now let's proceed to our home. I'm going to design a simple home screen in a file called home.dart. Return a scaffold, close this, and design it here. So I'm going to use initial root and then define my roots here, starting with home. Just remove the const. Okay, and then let's run this up and see it. Let's create the app bar. And give the title, the name of the app, let's work on the body. So we'll have a single child scroll view. This single child scroll view will hold a column. Let's define the children. So our first child will be text. Since we have this, let me just remove that. Set it in a safe area. So we'll have text widget that says shopping. Let's style it. Font size 22, font weight bold. Next we'll have another text widget. Next we'll have a simple text for description. Let me head over to the terminal and let's install Flutter pub add lorem ipsum. That will help us generate some text. Then in our column, I'll just define the cross axis alignment to start. And then let me define a padding. So I'll proceed to create another text widget. And we'll use a lorem. Let me just import it here. Import package Flutter. Thought we installed it. Let me check. Lorem ipsum. It's a different one. Okay, let me install the right one. What I need, Flutter lorem. That's the one that I need. So we need to remove const. Where is it? We have a const here. Yes. Nope. Okay. Let's proceed. So we have lorem. And this requires requires us to set some arguments. So we'll have paragraph. You can just set one paragraph and define words to be 10. That's better. Let me define the top. Okay, so that's a nice way to generate a description, a default description using this package. And then I'll just define the padding. Let's work on the next thing, which will be, we'll have an elevated button. Let's define a child that says create new list. And then style it. Let's give it a fixed size. Give it the height as 50. And then now let's work on the logic. So what is this button supposed to do? So we'll just create a pop-up using the show dialog. and then we'll proceed to return an alert dialog. The first thing we'll have is a title that says new list. Then we'll have the content, which will be a text field. So let's create a text editing controller. Let's name it as title, as we have been using. Text editing controller. And let's proceed to add that in our text field. Then let's add the actions. So we'll have the first one, which will be an outlined button. All it has to do is do a navigator.pop. Then it will hold a text that says cancel. Next, let's work on the next button, which will be an elevated button. And it will hold a child that says save. So in the logic now, what we'll do, we'll just check first if the user has entered anything. If it's not empty, then we'll proceed to create our shopping list. Let's see. I'll just proceed to call the shopping provider, shopping helper, our SQL helper. So let me just initialize it. We already have an instance in the main.dart. So let's just proceed to call it shopping helper. Then we call the function insert shopping list. Let me enter this. Then we'll design a model for it. Our model is called shopping list model, and it requires a title. So our title will be name title. I don't know, I keep saying name dot text. There we have it. And once you've done that, we can just do a set state, because below this we're going to have a list of the lists. Okay, so let me clear the just proceed here and say title controller just dispose, so it clears that the text editing controller, and then I'll just do a navigator dot pop, and we're done with the first part. So let's create a new list, and then when we're displaying them, we expect to see the ones that we have created. So I'll do a create list, and then we'll just enter the text home and click on save. So let's see if we'll be able to display that. So we head over to the next part. So this is the elevated button. So we'll have a future builder that will be listening to our specific function, which is get shopping lists. So I'll just define a future builder, and our future will be the shopping helper dot get shopping lists. Great. Then for our builder, we will first check if it does not have any data. Let's just return a simple circular progress indicator. Else we'll return a list view. Shrink wrap to true. Set the item count dot builder. Item count will be snapshot dot data dot length. It will be returning a list. And then let's design the item builder. So we'll return a card. I will have a child of list style. So we'll have a title. So we're going to pick our title from snapshot.data. Pick the specific index and pick title. So in case this data is empty, just set it as that. Then for subtitle, we need a subtitle. No, trailing, const icon, icons.keyboard, arrow right, and then on top it will direct us to another screen where we'll get to see the items of this specific list. So let me create a new screen here and call it shopping list dot. Give it to be a stateful widget and just give it the name shopping list. Return a scaffold. So we head over to our main dot and add this new root. Just say list. Shopping list. Okay. Then we proceed to on tap. When the user clicks on tap, we'll just do a navigation. And navigate to the shopping list. So let's refresh. We already see the home that we had created. I was just refreshing because of the root. So let's create another list, maybe school. Click on save. There we have it. So we're able to see our shopping list, and as you have seen that we are communicating with SQLite directly. We're not storing any information within the app. Okay, so now if we click on the home, now let's work on the next screen, which will have more operations to interact with. So one of the things that we need is the name of the shopping list that we are viewing. So I'll just create arguments for that. So let's just come here. So we need a type of that to be returned. So we'll just set it as a requirement. Then I'll just define the root name here. And then we'll access the arguments like this. Great. Now back to main, we'll need to change things up. So we'll just be calling shopping list dot root name, and then back to our home. Where is it? Over here. So we'll just proceed to call shopping list dot root name, and then we define the arguments, which will be as list arguments, and what we need to return here is this. There we have it. Now back to our shopping list. Let's design an app bar. And this will hold the name of the specific list. So we'll just say title, and we'll have a text widget that will have args.list.title. In case it's nullable, we set it as that. So define style it. Let's click on home. As you can see here, we have it. We don't even need to style it, it's just okay. So now let's proceed. So we have we'll have actions, and in our actions what we will have is an action chip. Our label will be a text widget, and what we'll be doing is giving the user the option to delete a list. So let's have an on pressed and add our logic. So we'll call the instance of our SQL helper and call function delete shopping list and specify our ID, which we'll get it from here. And we're done. And then I'll just do a simple, yeah, that's enough. Maybe do a set state. No, we need to go back, navigator.pop, because now the list will not exist. Yeah, as simple as that. Let me just pad it. Factor padding on the right. That's better. So let's try and delete it. Head over to home, delete it. So this part is not refreshed. Let's see. Let me just refresh it and see. So our home has been deleted. Awesome. So let's head over to school. Our delete functionality is working. Let's just head over to the body and work on the body. Inside our body, we'll have a future builder. And inside this whole future builder, it will be able to display all the information based on get shopping items of a specific list. Let me show you how. So just call the future builder, define the future. So the future will be the instance of our helper. Then we proceed to get shopping items, and we need to pass the list ID. So it will be args.list.id. The next thing we'll define is a builder. So for a builder, just do context, snapshot, and then we'll return a column. You can do a simple check and say if snapshot does not have data, return circular progress indicator, else proceed with our column. So now let's work on our column. We'll have our first child will be a row that will hold children. Now the first child will be we'll just say items. So you want to get the total number of items. So all I'll have to do is call the snapshot dot data dot length. This should be a string. Let me just do this right. So that, then there's this, then there is that. Remove that. So currently there are 0 because there are no items in this specific list. Next child will be, let's have a rich text. This part will represent the total sum of the prices of the items in this list. Let's style it. So let me just set a main axis alignment space between. Okay, let's proceed. Now let's design the children. Of type text span. So we'll have text span. And then the next text span. So this is just showing the currency. We're just assuming we're using dollars. And then now we need the next text span to hold the total sum. So for the total sum, we'll just create a simple function down below and call it get sum. The arguments that we need will be the list of type shopping list model and call it items. So we'll define a simple variable that holds the value 0. Then we do a for loop. Shopping list model item in items, and this is sum item dot price. Wait, it should be item. Great. So this is what we'll have, and then it will return the total sum here. So now let's go and use this. So in our text span, text span, for our text, we'll just call our method a function, then pass in the list, which we'll get from snapshot.data, and then whatever we get, convert it to string. So currently it's 0, fine. And then we'll let's just style it text style, font weight dot bold. We can leave it as is. Let's proceed to the next part. So this is the row. We'll have a text field. Let's define its text editing controller here. Text editing controller, and name it item controller is equals to text editing controller. And then we'll just proceed to add it here. And then can set a decoration, and with a hint text, just simply a hint text that says add item. Great. Let me just set padding on the whole feature builder. Where is it? Refactor padding. Let's say 20. And then we just want to handle whatever the user inserts. So if it's on submitted, we're expecting a value. So just check if a value dot is not empty. We'll proceed to call our SQL helper and call the function insert shopping item. So let's design our shopping item. So we'll have the list ID, which is args.list.id, and then we'll have the title, which will be the value that the user has inserted. Then for the quantity, we'll just set it to 0. For the unit, we'll just set it to empty, price to 0, and done as false. Done. So now that we have that, let's try and enter an item. Then we'll work on the next part below it where we'll get to view the items. So I'll just create a simple item like markers. Then I click on enter. Okay. So now that we have that, I think I should just do a set state. After creating this, I'll do a set state and just clear So we already have 2 items. I hope you can see up here. We already have 2 items in the list. So if I go back, click on this, we already have 2. Let me create something else like books. So it will clear, and we have 3 items now. Great. Now let's view our 3 items. So we'll have a list view dot builder. Let me just define the shrink wrap first. And then we'll have an item count, which will be snapshot dot data dot length. And then now we can design the item builder, context, and index. Sorry. So inside here we'll return a container, and the container will hold a child, which will be a row, and one of the children will be a column, and this will have a rich text. So the text will be snapshot. We want to get the name of the item, index dot title. We should be able to see the items, at least the names. Okay, let me just proceed with this. So we have the rich text. This, I think I need to style it so that we can see it. Yeah, that's the disadvantage of text spans. You have to style. Let me just style. We see if that's what we need to do. Font size 14. Now we can see them, our 3 items markers. We inserted 2 markers and another item called books. Now let's proceed. Next thing will be in our text span, we have our style. Then we'll just define children of type text span. Then our next text span will hold the quantity. So we'll just proceed to call snapshot.data. Let's pick the index dot quantity. And since it's of type double, I need to set it to string. Okay, next, we'll have another text span. Just copy this. This will hold the price. Let it hold the unit. There we have it, and it's this. The unit is of type string, so we don't need to make any changes on that. And then we'll have the next one will be price. Let's set the price here. It will be a text. I just copied the wrong thing. So we'll have a text snapshot dot price to string. We'll get to separate everything just in a minute. Column. We'll style it. So the one in bold is the price. It's supposed to be where's the list? But our container is not complete. Let me just finish on the container decoration so that it doesn't look. So we'll have a border, I'll use border.all and set the color as colors.black. And then for border radius, I'll just use the border radius. Dot circular. We have an error here. Let me refresh that. Okay. So we have our rich text that displays the quantity, the name, and the units. So for example, if it's for markers, it should be 0 markers, 0 pieces, 0.0. Where is 0.0 coming from? I think for quantity, we should have set it to int. That would have been way better. I'm considering where there's kgs, so maybe you want 1.5 kgs. So let's just leave it like that. But afterwards, we're supposed to have like units, for example, pieces and all that. And then now below it, we have the price. So I'll just do a cross axis dot start. Okay. I'll just do a padding on this. Is it necessary? Nope. Let's just set the padding within the container. Okay, that's better. And I think we should proceed to the next part, which is now what we're talking about, the icon button. So icon will be icons dot let's have that icons dot check. That means when the user clicks on it, that means they have selected it and they're in the shopping, they're doing their shopping. So they have that option to check on the ones that they've already bought. So that's what the feature is all about. And then we'll come here and set the color. And we're going to do a check. And this is where the attribute or the value, the property done comes in. So just say snapshot.data, pick the index dot done. If it's not equal to null, okay, and the same value is equals to false, we'll proceed to give it the color black. Else we'll give it we'll do another check. If it is, let's select all this. If it's not null and it's equals to true, we'll proceed to give it colors dot red, else colors dot black. So let's give it a weight. You should insert this inside here. Although the icon button does have that feature as well. So set the weight to 5. Zero 0.9. We'll get to see this in action in a few. So now I'll come here to the logic and we want to do an update. So if the user clicks, we need to set the update. If it was false and they've clicked it, that means they have selected it or bought it. That means we should change the done status to true. So we'll just come here, snapshot dot data. So just manipulating this specific object or this specific value without creating any other value. So we're just manipulating it, and then we take this and to our function, which is update shopping item. So I'm just saying set done to the current value not. So if it was true, it should be now false. If it was false, it should be true. Just set this inside a bracket. So if it was currently false, set it to true. If it was currently true, set it to false. If the user has selected and it was currently true, change it to false. That's all we're doing. And also for the snapshot dot, because we already have the list. Now let's proceed to call the SQL helper. So we'll have shopping helper dot update shopping item, and then we'll proceed to pass shopping this value. Sorry, this is the object that represents the shopping item model. And then we just do a simple set state. So let me try that. If I click on this, if I click on that, let me refresh. So we are losing the value, and I think I know why. We need to come here and specify the list ID as args.list.id. So let me refresh that. Click on school. I'll create, where did our text fill? Oh yeah, here it is. We need a padding at the top for this. Let me see. List refactor padding the top so that I can see the text field. So I'll enter books. There we have it. So if I click on books, it changes to this. Of course, there's more aesthetics that we can add, for example, like canceling out and all that, but I'm just using this for this tutorial. So the red means it has been selected. If I look at the container, we need to pad it as well to separate just at the top. That's That's okay. So now let's proceed. We have interacted with update shopping item. The next part will be, since we have selected this, we're just updating the done part just to give that experience where the user can know the ones that he or she has already put into their shopping cart. But now we want to be able to allow the user to update the values, the other information, because this one only updates the done feature, the done attribute or property. So I'll just come here, create another icon button. So we'll need an alert dialog for this. Show dialog. And then we'll proceed to return an alert dialog. Let's define our title, snapshot, content. We'll have a column, children. So we'll have, we need text editing controllers for price, quantity, and price, quantity, unit, and the title. So I'll just add them here. So we'll have price, we'll have quantity, we'll have unit, and we'll have title. Back to our column. You'll have a text field, controller, we'll have price, controller, decoration, const, input. We just need to set the hint text, which will be enterprise, hint text. So I'll just copy this, prepare for the quantity. So we'll have quantity, quantity, and then we'll have for unit, there we have it. Let me just set. Then after the text fields, we'll need actions. So we'll have an outlined button that will just do a navigator dot pop, and the child will be console text widget that says console. Then we'll have an elevated button. Let's work on our elevated, the logic that we need. So for the text fields that we have designed, we want to set them with the current values for those specific, the current values for the specific fields, that is the price, the unit, and the quantity, before loading the alert dialog, so that the user can know what they're playing with. If the price was 40 and maybe they want to change to 35, they get to see what's the current value. Okay, so to do that, I'll just simply set the text of these controllers to whatever is currently there. To string. I'll just do the same for the other three. So we'll have quantity, just pick quantity, and then we'll have unit. I'll just pick unit. We don't need to string, do we? Let's just set it to string. So that means the moment we open the alert dialog, let's try. If I click on this, it should display the values, which it is. Good. So now what we want to do is to enter some values, and we click on save. Okay, so this is what this should be doing. Dot data, pick the current index. I'm going to say quantity is equals to double dot pass whatever the user has inserted in the quantity controller dot text. So let's do the same for all of them. Let me minimize this for a minute so you get to see. Then there is, after quantity, we have unit. Unit controller dot text. We don't need the double dot pass. Then the next one is price. Just have price. So we have those three, and then I'm just want to save up the list ID again, just to make sure we don't lose our data. So this will be args dot list dot id, and then lastly we'll have yeah, that's all we need. Now that we have set that, we'll proceed to call our SQL helper, shopping helper, and call dot update shopping item, and set our item, which will be snapshot dot data index. Great. And then we'll just do a clear of, I'll just do a navigator dot pop, and do a set state. Then in our dispose, we can just make sure that our text fields are disposed. So it will be price dot dispose. We have quantity and we have unit. Great. So let's try and update and see. If I click on cancel, let's update markers. So for markers, I want to enter the price of $3, and then I just say I want 5 pieces. I click on save. So our values have been updated. Markers 5 pieces for $3. Great. We should be showing the dollar value here, but let's create a space between the so we have the quantity. We need a space between the quantity and the unit. Use interpolation. I just added it in the wrong place. That's fine. And for I think that's okay. So what else is pending? We haven't done delete shopping list. So we have the opportunity to set done, and then we have the option to update, and then we can add a delete feature here. Icon button, const icon, icons.delete. So there we have it, and then now let's call the logic. So all we have to do is call our SQL helper dot delete shopping item. Then we specify the ID, which will be the snapshot dot data. Pick the specific index dot oh yeah, it could be nullable. Okay, so this is a function that we're calling, and then I'll just do a set state. So let's try and delete books. So if I click on delete, the item is 1, and I had forgotten to show you the total that summed up to 3. So let's create another item, books, and then I just come and edit it here and say the price of $10 and say maybe 5 books, and click on save, and it's adding up. As you can see, we have 2 items. We're able to do a change. I may decide to say I need 10 of them. There we have it. And then if I decide to delete and click on delete, it will delete. So we've done the CRUD operation. We've been able to view items for a specific shopping list. We've been able to read them. We've been able to update, and we've also been able to delete. And also for the lists themselves, we're able to create a new list, we're able to view them, and we're able to delete a specific list. So all this we are doing inside SQLite. As simple as that. The user interface took some time, but the important thing was the implementation side of things. We were able to show how to create different parts of SQLite and how to interact with each and every part of it, from data migration to the CRUD operations. I hope you've gotten to see that. And there's the power of creating models for the specific objects that you have, so that you can be able to interact them easily inside your user interface, because all that we've done is just calling our functions from our SQL helper. So whenever you have such a situation where you need to interact with a database, an SQL helper class can really help. So we're done with a simple app. Now let's look at testing. Let's write a few unit tests that interact with the database, the SQLite or SQFlite. So we'll proceed to, let me just close all this. And in our test, we'll create a simple file called SQLite DB, SQLite DB test. And then it will have to install a specific specific dependency, which is called SQFlite common FFI. All it does, it helps us, it allows us to mock Flutter unit tests when we are not interacting with an emulator or an actual mobile device. So let's install that. So it will be Flutter pub add SQFlite common FFI. Great. Now let's work on our class. So first things first, we always have to start with the main function. And then we design our first test case. So our first test case will be open database. And then inside here, we'll proceed to add our logic. We'll set it to async. So we won't be mocking the, well, I say, so let's first initialize a default factory that we'll get to use. So we'll say it already exists, so we're just defining it to the database factory should use the database factory for the current package that we've installed. This one, the common FFI. If you end up using the database factory for SQLite itself, it's going to create an error. So that's all we're doing. Then we'll create a simple variable that will call our SQL helper that is already that we created in our lib folder. So we're not mocking the functions that are already in this, we're just using it directly. And then I'm going to define a path. In this shopping helper, let's proceed to it. I'm going to add another function. So what we want to do first is delete any existing SQLite database so that we can create a new, just to avoid getting an error where the database already exists. So I'll just create a simple function that will manage that. We'll call it init delete db. We'll give it a type of future string, because after that, after deleting, it will return a specific path. So first thing, we need the database name. Great. So let's define database path is equals to await get database path. Final path is equals to join. We did this in the main dot dot. Just passing the database path, and then we'll pass in the DB name that will be passed here. And then we'll just do an if else and check directory. If this specific directory exists, if it exists, we'll proceed to delete the database. So I'll just create another function here that will do that for us and give it the path to delete. I'll just set it as future void, set it as a sync. Actually, we don't need this. Just remove this and then just proceed to call the database factory dot delete database, giving it the path. Now let's call this here and give it the path. Done. Else we'll do a try and do an await directory. Specify the directory name and create that specific path. Recursive true, catch. You can just do a print of E, just leave it as that, and then we just return the path. So we'll proceed to use this init delete. And specify the database name. Now that we have that, we can proceed to open it. Shopping helper.open, and then let's proceed to create our next test case, which will involve the CRUD operations for our shopping list model. So we'll just define it here. Set our description as insert, query, update, and delete. Then let's add our logic. So inside there, we'll define the database factory is equals to the database factory FFI. This one refers to the one that comes with the SQLite FFI. This is because in the test case, we are not able to interact with SQLite itself, this database factory. This database factory FFI allows us to mock the SQLite itself, because you see the SQLite or SQLite is a local database, so it needs a mobile device or an emulator to be able to store the database and be able to for us to interact with it. But in our case, since we're doing some test cases, we're not using an emulator. The SQLite FFI is the one that you need to use. So it's a mock of the SQLite itself. So that's all we're doing. So we're picking the database factory that's usually found in the SQLite and initializing it with the database factory FFI, or better yet, you can end up using the database factory FFI directly. So there are two ways. So now that we have that, let's create an instance of our shopping list helper. So I'll just define it as shopping helper is equals to shopping helper. and then we'll define the path. So this is just equivalent to, we need to delete. First, we're just deleting what is there. We're imitating the same thing that we've done at the top in the first test case. So there are two ways of doing it. You can end up having this logic in a setup all functionality, so that with this specific logic, which is the same one that is here, it's executed before running any test case that we may have inside this file. So that's another way of doing it. So I'll just proceed. Next thing we're going to do an await, similar to this one, an await shopping helper. Right, now that we have that, we've been able to open the database. Now let's create a simple shopping list model. So I'll just say var list, create a variable of type shopping list model. And what we need to pass in is a title, so we'll give it home. Now that we have that, we want to insert it in our SQLite. So we'll just call in our shopping helper dot insert shopping list and pass in the list. Great. So what do we expect? So first we expect that the list dot id is equivalent to 1, right? And then let's do list is equals to await shopping helper dot get shopping list and pass in 1. Insert it like that. So this list will contain a model of this type. So we're getting a shopping list by the index 1. So we're expecting to receive whatever we have inserted. So let's just add that logic. Expect list.id is equals to 1. And then another expect that we can do is expect list.title is equals to home. So let's try and run this and see. So there we have it. Our tests have passed, both open database and the current one that we're working on. So let's proceed. This is mainly insert. Let's proceed to the next one quickly. So the next one will be, we already done insert and we've done get. Let's do an update. Okay, how we'll do it is I'll just do a straight expect statement and we'll do an await shopping helper dot update shopping list, and we'll pick our list dot title and set it to school. Better yet, let me just update that, sorry. So I'll just say list dot title is equals to school, and then I just proceed to pass our list with an updated title. And what we expect is, so at the point of update, let's just head over to a function. Once it has updated, it returns the ID of the updated value model, which is our list. So we expect the ID to be 1, right? So that's how we're going to insert it. And then another expectation will be, I'll just do an expect list dot title is school. That means the the object has been updated. So let's do also the delete so that we can finish this. For delete, we'll just do an await shopping helper, delete shopping list, and we're going to pass in the id list.id. Let's just set it as 1, and we expect a null. So the moment this specific value is deleted, let me just check on our, so our delete shopping list, once it's deleted, it returns the deleted id. So what we need here is 1, the value of the deleted. Then we do an expect await shopping helper dot get shopping list. So we expect it to be null because we have deleted it, right? So now let's run all this. So just to take a short, let me take you through quickly. So this part is only to open the database, which is equivalent to this test case that we've created. And I've mentioned that instead of repeating again, you can actually set it in a setup all or a setup test case method using this setup all method. And then the next thing we have done is we've created a simple object for shopping list, and then we've proceeded to insert it in our SQLite. And then what we're expecting is the id of this new value that we have inserted is equals to 1, right? Then when we proceed to get the shopping list, this is what we're expecting. Again, we're just doing a get just to show the concept of crude read. And then when we also read the home, it should be home. Okay, now we have changed the model to the title of the specific model to school, from home to school. So what we're expecting when we update this, of course, what's being returned here is the ID of the updated object. It will return 1, which is this one, the object that we have created. And then we also expect the title to be the value, the new value that we have changed in our object. That's update. Lastly, we have delete. So what we've just done, we're saying what we expect when we delete this shopping list. What we did in our function is it returns the ID of the deleted object, which is 1. And also what we're doing now after deleting, we want to try and get that value by that ID and see if we get anything. What we expect is that it should be null. So that's simply what we have done. So let's run our test cases and see. Let me just do that again. It's moved so fast. Okay, let me just run the main method. So let me run this again. There we have it. So all our tests have passed. That was quite simple. So if you want to work on this is insert query update delete for lists. So we can just do the same now for item. And just set this to items, and then we'll just proceed to delete. This is just the same logic. Then we'll have item, and what will be returned, creating an object of shopping item model, which has specific attributes. Let me just change that. So we have a list ID, which will set it to 1. We say an item for groceries, and then quantity will be 1, unit will be kgs, price will be, and then done will be false. So there is our object. Next thing we'll do an insert shopping item and insert our item. So we're expecting our item.id to be 1. And then if we want to get the shopping item, we use a get shopping item, which is one item.id, item.title, which will be groceries. Then let me decide to change the item title to, or let me change done to true, which is a boolean. And then we want to update the shopping item, so it returns 1. But what we want to check is whether done has been set to true. And then we can proceed to delete our shopping item and get shopping item. So it's similar. So let's just run this. So we have an error. Let me check what that is. I think what's the mistake, I know what I've done. You recall when we said that let me see, begin while executing database is locked. Database is locked, causing, wait, invalid SQL argument of type bool false. Okay, that's not even our issue. Our issue is mainly on this part. So you recall when we were designing our shopping item model, I had mentioned that in the SQLite, we do not have true or false. We don't store true or false. We store either 0 or 1. In SQLite, it's able to convert whenever you pass true or false, it's able to convert into integer. Remember I mentioned that what is stored in the table is integer, 1 or 0. So if it's true, 1, if it's false, 0. Okay. And now the SQLite common FFI doesn't know how to convert that. SQLite could easily convert that for us. If you recall, we were just passing our model with the value of for done as false or true, and there's a way it could be able to convert to the specific integer. True should be 1 and false should be 0. But this specific package doesn't know how to do that. So what I have done is we had insert shopping item and we have update shopping item. This is where our errors come in at the point of inserting this model, which has our done attribute has the word the boolean false, and at the point where when we updating our item, we have our attribute done, we have updated to true. So that's where the error will come in. So what I've done is in our shopping helper, we have okay, let me just head over to here. So what I've done in our model, I've just created a mock of this. So we had this, right? So I've just created a simple mock of this, which you can recreate in the test case itself, but just for easy understanding and not taking your time, I've just created another mock here. This is a mock that now will check if the value is true, convert it to 1, else convert it to 0. So in SQLite it's able to manage this, but the other package is not able to. So we've just done that for it. And then instead of calling insert shopping item, we have created another mock function for it here, and all we have changed is instead of calling to map, we're calling to map mock. That's what we're doing. So what we're going to call is insert shopping item. The same thing I have done on update. We had update shopping item. I've just created a mock function for it by calling, and then it will end up calling to map mock instead of to map. So now let's change those two. So this will be insert shopping item mock, and this will be update shopping item mock. So you can replicate the same logic inside here. Instead of having another function for that, you can just replicate this concept inside here. I'm just trying to make it simple and brief. So now that we have this two, it will be able to convert for us these values, these two. If this is false, it will end up saving the integer as 0, and this one it's updating to true, it will update it to 1. Now let's run our test case. Great. And we have our test case that has passed. So we have mainly performed CRUD operations on the shopping item model and CRUD operations on the shopping list item model. We've gotten to see how to use the SQLite common FFI. Despite it being a mockup, we have seen that there are certain things we just have to add logic on. That's in SQLite, that's not in SQLite common FFI. So with that, and then you can proceed to expand this test case. I just make it as simple as possible for you to actually execute a few test cases, but there's so much you can do with this test file. Great. Now let's proceed to the next. Let's have a look at best practices and tips when interacting with SQLite in Flutter. Always initialize the database when your app starts or when the relevant component is created. Use a singleton pattern for the database connection to avoid opening multiple connections. Also, implement versioning to handle database schema changes over time. We've gotten to see that. Wrap database operations in transactions to ensure atomicity, consistency, isolation, and durability. If you don't know what ACID means, please have a look. Then handle exceptions appropriately to prevent crashes, and also it improves the user experience. Then use bulk transactions or prepared statements when dealing with multiple records that do not require user interactions. Then implement a backup and restore mechanism to prevent data loss. Unfortunately, SQLite does not have this feature, therefore we have to code our way through some custom functionality depending on our project needs. And lastly, write unit tests for your database operations to ensure that they work as expected. So we are in the final part of this tutorial. We've gotten to interact with SQLite, understand its importance, where it can be used, where it cannot be used, its drawbacks and benefits, up to a point where we have done some few test cases and created an application, a full application. So please feel free to dive into the comments below and maximize our discussion on this topic. Until then, subscribe, like, share, and I'll see you on the next one.